Welcome to Further Mathematics class. In this class, I'll be taking you through inequalities. The lesson outline include basic rules of inequalities, linear inequalities in one variable, quadratic inequalities in one variable, and absolute values. Basic rules of inequalities. The first rule is if A is less than B and C is greater than 0, then A plus C is greater than B plus C. B. If A is less than B and C is greater than 0, A plus C is less than B plus C. The same constant can be added to both sides of the inequalities. Example 1. 3 is greater than 2. It means the same constant that is greater than 0 is 4. And that is the reason why 3 plus 4 is greater than 2 plus 4. And the same is applicable to the second question. 2 plus 3 is less than 5 plus 3. Rule 2. If A is greater than B and C is greater than 0, then A minus C is greater than B minus C. B. If A is less than B and C is greater than 0, then A minus C is less than B minus C. The same constant can be subtracted from both sides of the inequality. Example 2. The first question is 5 is greater than 3. The same constant that is greater than 0 is 2. And that is the reason why 5 minus 2 is greater than 3 minus 2. The second question, 4 is less than 7. And 4 minus 3 is less than 7 minus 3. The same constant that is subtracted from both sides is 3. Rule 3. If A is greater than B and C is greater than 0, then AC is greater than BC and A over C is greater than B over C. The B part, if A is less than B and C is greater than 0, then AC is less than BC and A over C is less than B over C. If both sides of the inequalities are multiplied or divided by the same positive number, then the sense of the inequality remains unchanged. Example 1. If 10 is greater than 8 and 2 is greater than 0, it means the same constant is multiplied, which is 10 times 2 is greater than 8 times 2. The second part of the question is 2 is a constant that divides the number at both sides of the inequality. 10 is divided by 2 and 8 is divided by 2, and the same is applicable to Roman figure 3 and 4. Rule 4. If A is greater than 0 and C is less than 0, then AC is less than BC and A over C is less than B over C. B. If A is less than B and C is less than 0, then AC is greater than BC and A over C is greater than B over C. If both sides of the inequality are multiplied or divided by the same negative number, then the sense of the inequality is reversed. Example 5. 5 is greater than 3, minus 2 is less than 0. So the value of constant that is less than 0 is minus 2 minus 3. That's the reason why 5 is multiplied by minus 2 and 3 is multiplied by minus 2. And the second part of the question, minus 2 is a constant that divides 10 and 8 at both sides and is applicable to Roman figure 3 and 4. Rule 5. If A is greater than B and C is less than D, then A minus C is greater than B minus D. B. If A is less than B and C is greater than D, then A minus C is less than B minus D. Example 5. What this means is that C and D are subtracted from both sides of the inequality, irrespective of the signs. Now, 2 is less than 4 in the first example, and that is the reason why 2 is subtracted from the left side of the inequality, and 4 is also subtracted from the right side of the inequality. The second part of the question, 3 and 1 are both subtracted from both sides. Rule 6. If A is greater than B and n is greater than 0, then A raised to power n is greater than B raised to power n. Example 6. The value of n greater than 0 starts from 1. It can be 2. But in this case, 2 is greater than 0. It means the value of n is 2. Then 5 is greater than 3 and 2 is greater than 0. It means 5 raised to power 2 is greater than 3 raised to power 2. The B part. If A is greater than B, then n is less than 0. A raised to power n is less than B raised to power n. It means the values that are less than 0 start from -1, -2. And in this case, the value is -2, and that is the reason why the power is -2. Rule 7. If A is less than B and n is greater than 0, then A raised to power n is less than B raised to power n. Example 8. 3 is less than 8. It means the value of n greater than 0 in this case is 2, and that is the reason why 3 raised to power 2 is less than 8 raised to power 2. The B part. If A is less than B and n is less than 0, then A raised to power n is less than B raised to power n. Example 9. The value of n that is less than 0 in this case is -3, and that is the reason why -3 is a power in both sides. That is, 4 raised to power -3 is greater than 6 raised to power -3. Linear inequalities in one variable. In solving linear inequality in one variable, the rules of division and multiplication by a negative number reverses the sense of inequality. Example 10. Find the solution to the inequality 3x plus 4 is greater than 1 minus 2x. Solution. 3x plus 4 is greater than 1 minus 2x. Collect the like terms. The like terms are 3x and minus 2x, 4 and 1. So that's the reason why when -2 moves to the other side, this becomes plus, and you have 3x plus 2x is greater than 1 minus 4. Therefore, 5x is greater than -3. Divide both sides by 5. Therefore, x is greater than -3 over 5. Quadratic inequalities in one variable. To find the solution set of the quadratic inequality of the form ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is less than 0. If a dot b, dot means multiplication, is greater than 0, then either a is greater than 0 and b is greater than 0, or a is less than 0 and b is less than 0. If a dot b is less than 0, then either a is less than 0 and b is greater than 0, or a is greater than 0 and b is less than 0. Example 11. Find the solution set of x squared plus x minus 6 is greater than 0 and show this on the number line. Solution. If x squared plus x minus 6 is greater than 0, by solving this quadratic inequality, x minus 2 and x plus 3 is greater than 0. Either x minus 2 is greater than 0 or x plus 3 is greater than 0. Therefore, x is greater than 2 and x is greater than minus 3, or x minus 2 is less than 0 and x plus 3 is less than 0. Therefore, x is less than 2 and x is less than minus 3. That means that when you substitute the values of x less than minus 3 and x greater than 2 into the given quadratic equation, it must give you the result that is greater than 0. Representation on the number line. On the number line, x is less than minus 3, and that begins with minus 4, minus 5, and so on. And also, x is greater than 2, and that begins with 3, 4, and 5. It means when you substitute these values into the given quadratic equation, the result must always produce numbers that are greater than 0, absolute values. If a number x is positive, the absolute value of x denoted by the modulus of x is x itself. If the number x is negative, the absolute value of x is minus x. The absolute value of x, sometimes called modulus of x, is defined precisely as the modulus of x is equal to x if x is greater than 0 and is minus x if x is less than 0. Example 12, the final example. Find the solution set of the modulus of 2x minus 3 is less than 4. Solution. The modulus of 2x minus 3 less than 4 means that minus 4 is less than 2x minus 3 less than 4. This inequality can be expressed in two ways, which is 2x minus 3 is greater than minus 4, or 2x minus 3 is less than 4. And by solving the two sides together, 2x is greater than minus 4 plus 3, or 2x is less than 4 plus 3, 2x is greater than minus 1, or 2x is less than 7. Therefore, x is greater than minus 1 over 2, or x is less than 7 over 2. The solution is x is such that minus 1 over 2 is less than x less than 7 over 2. Thank you for listening.